Hey everyone, and welcome to this professional explainer. Today, we're going to unpack the really rigorous site management and execution methodologies that are absolutely essential for modern construction projects. So whether you're an undergraduate engineering student, an aspiring project coordinator, or maybe a seasoned site supervisor looking to benchmark your skills, this masterclass is definitely for you. We're going to look right past the dirt and the noise to see the highly structured, meticulously planned ecosystem that actually makes multi-million-dollar mega projects possible. Let's get into it. Okay, let's quickly map out our syllabus for today. Our modules will cover the site engineer's role, blueprints and quantities, resource management, execution and quality, and finally, construction reporting. All right, let's kick things off with Module 1, the site engineer's role. You know, a site engineer really isn't just a manager. They're the technical problem solvers out there, ensuring that a 2D design becomes a safe, fully compliant physical reality. Basically, they bridge that incredibly critical gap between the theoretical math being done in the office and the heavy machinery moving earth outside. Now, what's truly fascinating here is the sheer breadth of their daily responsibilities. On a micro level, they need this intense attention to detail, like checking drawing accuracy or setting out the site with precise leveling tools. Yet in the exact same breath, they have to completely shift gears to macro-level management. We're talking overseeing workforce safety and liaising with local authorities for compliance. It requires a massive amount of cognitive flexibility. And this perfectly illustrates the spatial puzzle they've got to solve before ground is even broken. According to the REBA plan of work, site logistics are absolutely paramount. Think about it. Where do materials arrive? How do we route those massive cranes safely? Where do we put the mandatory welfare facilities without blocking access? Even minimizing neighborhood disruptions with things like wheel washing and careful generator placement falls under this critical logistical umbrella. Moving right along to Module 2, Blueprints, Estimation, and Quantities. Successful execution requires flawless, multidisciplinary coordination. You've got architectural drawings dictating the space, structural drawings detailing the reinforcements, and MEP drawings routing all the HVAC and plumbing. If these aren't cross-referenced correctly, which is often done using modern BIM software these days, you can end up with extremely expensive disasters. Imagine a structural beam totally blocking an essential ventilation duct. Not good. So once the drawings are reconciled, we measure the work using standard units, like the ones in the IS 1200 code. Engineers rely on specific takeoff techniques here. You have the centerline method, which is generally faster for symmetrical buildings, or the long wall, short wall method, which is highly accurate for individual wall sections. Both are critical for calculating precise volumes for earthwork and concrete. And all of this builds directly into the bar bending schedule, or BBS. This tracking document is quite literally the lifeblood of structural integrity. It dictates the exact length, shape, and size of every single piece of rebar. A tiny calculation error here doesn't just waste thousands of dollars of steel. It can actually compromise the safety of the entire building. Let's dive into Module 3, Resource and Budget Management. When we say resources, we're talking about way more than just raw materials like wood, cement, and steel. Resources encompass the heavy equipment like excavators, a highly diverse labor force ranging from estimators to site workers, mandatory on-site facilities, and, crucially, the financial capital that keeps the entire project breathing. We can actually break the resource management process down into sequential steps. First up, we conduct a material takeoff analysis to list out quantities based on our blueprints. Second, we define the scope of work, which is the contract defining everyone's obligations. Third, we forecast the cost of all labor, materials, and equipment. And finally, we build a padded, rigid construction budget to protect our profit margins from those inevitable, unexpected expenses. Now, once that budget is firmly locked in, the execution phase demands constant vigilance. Step 5 is acquiring resources and partnering with reliable suppliers. Step 6 is allocating and tracking utilization. You want to completely avoid labor bottlenecks where expensive crews are just standing around waiting for materials. And Step 7 is relentlessly monitoring costs against your initial baseline. Tying this whole financial module together is the BOQ, the Bill of Quantities. This document demands incredibly strict billing procedures, deep rate analysis, preparing interim payment certificates to keep contractor cash flow healthy, and carefully managing change orders. You need to ensure that every extra brick or beam added to the scope is precisely calculated and compensated. Which brings us to Module 4, execution, labor, and quality control. Before we even think about looking at productivity, we absolutely have to look at safety. Safety and compliance, particularly adhering to rigorous international and state standards like OSHA, as well as strict labor laws, are the non-negotiable bedrock of site management. Let's be real, without a safe site, all your beautiful budget planning goes right out the window. Once those safety protocols are firmly in place, managing contractors and optimizing labor productivity becomes your daily battle. This requires daily, sometimes hourly allocation adjustments. You're organizing specialized subcontractors, managing daily attendance, and constantly tweaking workflows just to reduce idle time and ensure absolutely no budget is wasted on site. Meanwhile, QA/QC runs parallel to labor management. It demands relentless material testing, things like concrete compressive strength and slump tests. Crucially, it requires the immediate issuing of nonconformance reports, or NCRs, the very second a structural error is identified. Why? Because fixing wet concrete is cheap. Breaking down a cured, non-compliant concrete column, that is an extremely expensive nightmare. Finally, we've reached Module 5, Crucial Construction Reporting. 10. According to industry best practices, there are exactly 10 commonly used construction reports that serve as the project's dashboard for progress, safety, and financial health. These aren't just tedious paperwork. They are literally the lifeblood of project visibility. By categorizing these 10 reports into operational, financial, and safety buckets, site managers can maintain total visibility over every single facet of the build. You have your feasibility and risk assessments driving the initial planning, your job cost and WIP reports tracking the financials, and your inspection and incident reports documenting the actual safety reality on the ground. Out of all of them, the daily construction report is particularly vital. It logs everything, from temperature and wind speed impacts to exact crew timesheets and equipment usage. If materials are delayed, it gets recorded here. If visitors come to the site, they're logged. It forms an ironclad legal and operational record of the site's daily heartbeat, which protects contractors from litigation down the line. And as we finally approach the handover phase, the punch list report takes center stage. This report dictates the final minor fixes required, whether it's an incorrect installation or slight damage to finishing materials. Every single item on this punch list must be corrected before the project is officially closed and the contractor receives their final payout. So having unpacked this complete syllabus of site management, we've seen how everything from the bar-bending schedule to the daily report intricately connects. The ultimate question I want to leave you with is this. In an industry with zero margin for error, how will you apply these exact standards to guarantee the safety and profitability of your next mega project? Thank you so much for joining me for this explainer. I hope you found it as fascinating as I did. Catch you next time.